Hello, everybody. My name is Peter. I'm a staff developer advocate on the Firebase team. And today I was at an event that was hosted at the Google Campus for Startups right down the road. And it was sponsored by Google Cloud. That's why I wear a Google Cloud t-shirt. But today the talk will be mostly about AI with Apple Intelligence and Apple's foundation models and Gemini. So quick show of hands, who has used Apple foundation models before? All right, so that's a good chunk of people. Who has used Gemini, like any part of Gemini? All right, so that's almost everybody. Amazing. So, and I want to apologize for Google's naming. It's hard. We try our best. So, a little bit about me. I live in Hamburg. And I get to travel around. Any guesses where that might be? Amsterdam. That's the Google office in Amsterdam. I am a developer advocate on the Firebase team. And I'm also an iOS fanboy. So I try to blend Firebase and iOS development, which is why I built this Doxy interactive tutorial that you'll be able to find on my website about SwiftUI and Firebase, and it teaches you how to replicate the Apple's Reminders app using SwiftUI and Firebase. And then, because I built lots of SwiftUI stuff, I ended up building a tutorial for creating reusable SwiftUI components as well. All of that is free on my website. I get to record amazing videos, either from our studios, that one is in the basement in King's Cross, or I stream from home, and I also run a newsletter that you can subscribe. And here is the QR code, and please scan the QR code because I just smashed an avocado for it. So I gave a version of this talk at NS London 2024. And I showed an application that is called Codename Sophia, and is basically a read it later app. So you can collect links to any interesting articles that you come across and don't have the time to read using an iOS share sheet. And the application will use Open Graph data to extract who is the author and other interesting details. It will simplify the formatting, which is a euphemism for it will reduce the amount of ads in the articles. And it will store the article in Cloud Firestore, which is a cloud-based, NoSQL, document-based database that allows you to synchronize data in real time. So everything that you store in Cloud Firestore is also cached offline on your device, and so it's super easy to tap into that data and read your articles offline. For example, if you are in a plane, if you are in a tunnel, or in Germany, if you are in a train. And then, in the meantime, AI happened. And also liquid glass happened, right? So I migrated that application to liquid glass, and I added a bunch of AI features to it. One of them I thought would be a nice idea to explore how foundation models work like. So who here has used foundation models before? Let's just double check. Same people? Amazing. So foundation models enable you to run inference on your local device. And inference is just a fancy word for you are using an LLM to compute the answer to a question. So if you do that on device, you've got a couple of benefits. So the first and obvious benefit is that it is available offline. So this all works without you having to be connected to the internet, which is a really huge benefit. Another huge benefit is it comes at no cost. So the only cost that you incur is that it might cost you a little bit of battery, so the user has to charge their battery at one point, but we can just neglect that. It's private because the data doesn't leave the device. So let's take a look at how this works. So in my application, I've got a feature. Let's imagine that you've just stored an article that you want to read later, and then you come to the article and you think, oh my gosh, this sounds like an interesting topic, and I did want to read it later, but I don't have time. So you can tap on a button and it summarizes the article for you. And here is the prompt that we use to do that. It starts with a task that says, please create a short and snappy informative summary of the following text. And then we have a couple of constraints. For example, it must be a single paragraph, no more than 3 sentences. You need to capture the most important takeaway, and it must be easy to understand. And then the text follows. Then we provide the input, and that input is what you read from the database. So in my case, that is what I read from Cloud Firestore, which is, in that moment, stored on the device in the local cache. The next step is you instantiate the language model session, which interestingly, and that is one difference to how this works on the Google side of things, always is a chat interaction. Right? So even if you do single shot, it is still a chat. So we provide the instructions to the language model session, and then we tell the session that we want it to respond to the input. So the session now has the system instructions, it has our input, and it can now react. And that is an asynchronous operation, might take a couple of moments, and then we get the response text back, and then we can do whatever we please with that response text. In my case, I take that summary and store it into the notes field for the article that the user saved, so that they can always come back, and instead of reading the article, they can read the summary. So let's do a demo. And I'm going to run this demonstration on my iPhone 13 Pro simulator. And you will see why in a moment. Okay, so if you do anything that involves compiling or AI, you need to have a good jog. Let's see if I need it. No, I don't. Okay. So this is the application, and if I go into my inbox, let's say I want to get a summary for this article here, and then I can go in, click here, and then pay attention to what's going on in the log. Okay, so we don't want that breakpoint at the moment, and that we don't want as well. So now, it's saying attempting local inference. And it also, at the bottom, it says summarized locally on your device using Apple Foundation models. Who can tell me what's wrong with that?
Shouldn't display this?
It shouldn't just, okay, well, that text, that is just for me, it's like a debug statement. So that's on purpose. But should an iPhone 13 Pro be able to run foundation models? No. So the simulator is lying to us. And that is why I brought this device. I completely forgot to bring an iPhone test device, but this one is an iPad 11. And let's see if I can pull it up here. And then we will run the same application on that device, and then we'll see what happens. So, oops. Oh, that's why. Come on. Why is it not letting me resize the simulator? Anyways, so, and I somehow typed something in here. So let's try again. So we're building, and it failed. Why? consecutive declaration. What is happening here? Should be a bool. There you go. Okay. So here's the application. Fingers crossed. Okay, so, and now let's go into an article. And let's take this one. And then let's go in here and tap the please summarize this button. And now we have another breakpoint. And this breakpoint is somewhere else because it, oh, you can't see it. Why didn't anybody tell me anything? Okay, so did you see what happened? No, you didn't. Let's do it again. Okay, so I'm going to tap the button. It will run the inference, and then it says, summarized remotely using Firebase AI logic. And that is exactly what I wanted to happen, because this device does not support foundation models. So when I tried to infer locally, it realized, oh, I don't have foundation models, so I need to use a fallback. So how does that work? So the on-device drawbacks that we saw are, it's not available on all phones. Old phones don't have foundation models. It's not available in all regions, and that depends on the state of the rollout, right? So in some countries, in some regions, it might not be available yet or not at all. The model might not be downloaded yet. That's another issue. Or, God forbid, your administrator might have disabled the feature using a mobile device management policy. So all of these are moments when your application won't be able to use foundation models because it might not be available. And then we have another problem, and that is the token window size. So foundation models have a token window size of 4,096 tokens, which is enough for most things, or for many things. But if you have a long blog post, that might actually be too much. So let's talk about hybrid. What does hybrid mean? Hybrid means a thing made by combining two different elements, or it means of mixed character composed of different elements. So made by combining and mixed character. So let's take a look at how we can use that to our advantage. So the requirements that we want for a hybrid AI solution is we want an automatic fallback. So if I realize that I don't have access to foundation models, I want to fall back to something else. And that something else might be a cloud-based model. It might be Gemini. It might be OpenAI. It might be Anthropic. It might be anything that you like. Or it might be a locally running model that you host on Ollama. I want to be able to specify a priority, and that means I would like to prefer local inference in most cases and then fall back to remote. But sometimes I might prefer to use remote inference, and only if I can't use remote inference because the cloud is not available, maybe I'm offline, then I want to fall back to local, right? So I want to have choice as a developer. Or maybe as a developer, I also want to give choice to my users. I want to have a unified API, and that means I want to be able to use that transparently. I don't want to care about, am I using the local inference? Am I using the remote inference? I want a unified API no matter what happens. And I want this to be extensible. That's always good. And configurable, right? So I want to be able to use different prompts for local inference or for remote inference. And you might be asking why. And one of the reasons is because of the token window size. So if you have a token window size that is small, like 4,096 tokens, your prompt might look different or should look different than if you have a token window size of 1 million tokens. So you need to think a lot harder about how you can write a good prompt that doesn't use much of your token window already. So who here knows this book? Show of hands? Okay, a few. So I'm going to date myself. I bought this book when it came out in 1995 because I went to uni in that year. And it is a book about design patterns that teach you how you can structure your application. Many people fell into the trap of trying to use all design patterns in their applications, which is obviously not such a great idea. But today we are going to look at one pattern, and it's called the strategy pattern. And here we see all the participants. So we have an interface, and that is the inferencer. So that is what we use as developers. So that is the face to the API, if you will. And it has a couple of properties. For example, is available. That tells us, is the inferencer that we want to use available? We have instructions where we can provide our system instructions. And then we've got the infer method, which will actually perform the work that we want to do. And then we've got a couple of implementations. We've got the remote summarizer, and we've got the local summarizer. And the remote summarizer, as you might imagine, uses the cloud to perform the work. And the local summarizer uses a local LLM to perform the work. And then we've got a summarizer service, and that summarizer service uses an inferencer to perform the work. And you can see that the summarizer service has a map of inferences. And that map helps the summarizer to understand what kind of summarizer it is. Is it a local? Is it a remote summarizer? And then it can choose which one it wants to use. And it also has this summarize method here that you can call. So inside the summarizer service, we will iterate over all the available summarizers and then pick the one that matches our strategy best, and then use that to perform the work. Here is some code. So that's our protocol for the inferencer. And the is available property tells us, can we use this inferencer? So if I call that method on my iPhone 13 Pro, it will say, no, sir, you can't, because this is not available. If I run this on a physical device, it will say, yes, it's available, if it's an iPhone 17, for example. And on the simulator, you just saw that the simulator is lying to us, which I think is a little bit unfair, because the simulator basically just tells us, well, the device that I'm running on, which is my MacBook here, is capable of doing that. And then we've got the infer method, which does the actual work. And we have our instructions. So here is our local inferencer. And you can see that we can now add our instructions here. So this is the prompt that we will use when we use Apple's foundation models. The isAvailable method does a couple of things. So first of all, it checks if the application is compiled against iOS 26. And if so, it will try to call systemlanguagemodel.default.isAvailable to figure out, is this available at all, which is a good indicator. And if the model is available but not yet downloaded or is disabled, then we get false. And then we have the infer method, and that, again, has an availability check. Why? Because between the time that we invoke isAvailable and we invoke infer, some time might have passed, and let's imagine the user has just downloaded the app on the fresh iPhone. The model has not yet been downloaded, so it says, I'm not available. But a time later, maybe a couple hours later, they try the feature, and then the inferencer says, well, actually, it's not available. Or the other way around. The user installed the application, and after installing the application, they disabled the model. And then we also need to gracefully handle that. And that is why we perform this additional check up here. That is the same code that you saw before. So literally just setting up the language model session, passing the instructions, passing the input, getting the response text. And now let's take a look at the remote inferencer. And that is based on Firebase AI logic. So when I asked about Gemini, almost all hands went up. Who here has heard of Firebase AI logic before? All right, so 3 people, 4. That is wild. So Firebase AI logic basically is an interface to Gemini, and it allows you to use Gemini in a secure way. If you were to call an LLM, a cloud-based LLM, from your mobile application, what you need is an API key. So where do you put that API key? I know you won't do it, but many people will put the API key in their application, and that is a very bad thing because any malicious actor can download your app from the App Store, can decompile it, find that API key, and then abuse it. They can just use it to drive their own business, and the poor app developer has to pay for it. Firebase AI logic does away with that because the API key doesn't have to be stored on the device. Actually, it's never stored on the device. But in fact, we handle that in the background for you, all on secure servers in Google data centers. So the API key never leaks to any malicious actor. So here is how we implement the remote summarizer. So the availability here obviously depends on other factors. For example, you might perform a network availability check, or you might perform a check, is the Gemini API enabled on the respective Firebase project? So these are all the things that you would check in is available. And then in order to actually perform the inference, you will first need to set up a model. And here's how we do that. First of all, I read the model name from remote config. Remote config is a service that Firebase provides, which allows you to configure aspects of your application in the cloud and change them and roll them out to your users. And because models change all of the time and they get sunset and deprecated all of the time on a regular basis, this is something that you don't want to compile in your application. You don't want to have a hard-coded string of the model name in your application. Rather, you want to be able to remotely control which model your application uses, so you don't have to scramble to ship an update and pray to the gods that Apple will approve your update. So that is why we use remote config to ship the model name. And once we set up our model, we can call generate content, and in our case, compute the summary of an article via Firebase AI logic. We will then use Gemini to do that. So, and now we've got our summarizer service. The summarizer service, as you remember, is the thing that uses the local inferencer or the remote inferencer to perform the work. So first of all, we will iterate over all the registered summarizers in priority order. And that priority order might either be something that you define locally, or again, that you define in remote config, which gives you ultimate freedom to control how your application behaves. Oh, sorry. So we have this loop, we go over the loop, and then we call the inferencer, and if it works, then everything is good, and if not, we will check the next inferencer. So let's take a look at how this looks like in the application. So let me actually add a new article. So Piotr talked about Xcode agentic coding. So if you want to use Gemini to do agentic coding, you can come to my website and read all about it. But if you don't have time, you can share that into my Read It Later app. We'll add that. And then we'll go in here. Here is the article. And now I can go and summarize that. So it will probably use local inference. Yes, it did. And now let's change how it works. So here we are in the remote config console for my project, and you can see a bunch of things here. So for example, I have a setting that allows me to control the prompt for my local inference. So if I realize, well, that prompt doesn't seem to work that well, I can just change it here and then roll it out to the application. And I can do that in a controlled way. So I can roll it out to 5% of users, 10% of users, 75% of users, 95, and then 100. And all along the way, I can decide, oh, is it working? Or do people report more bugs than before? Or does the application do some funny things? And then I can easily roll back. So that's one of the advantages of using something like remote config. I can also enable or disable the local summarizer altogether. I can change the remote model name that I want to use. And here we use Gemini 2.5 Flashlight, which is a little bit dated. So I could say, well, let's use Gemini 3 Pro Preview, for example. And I can also completely disable the feature by going in here and saying, you know, I don't want this feature to be enabled. So actually, let's try that. So for example, I realize, oh, it's, you know, I want people to read the articles and not summarize. So I changed that, and then I'm going to go ahead and publish that. And it's published. So let's take a look. So in the log, it says successfully activated and updated properties from real-time update. So for those of you who have used remote config before, you might know that remote config in the past only allowed you to get a remote configuration update when the application started up or when you polled the backend. And then lots of people would do continuous polling. And we thought that's not such a great idea. Let's implement something that is better for us and also better for developers. And that is why we shipped real-time remote config. And so without having to restart the application, I can now, and hopefully this works. Oh no. Okay, so it didn't work. Let's see if it was just this bad state update. Nope. I'm so sorry. So it should say, sorry, sir, you can't do that. Let's try something different. So let's try updating the prompt. Please always add hello Warsaw to the end of the result. So hopefully that works. Publish changes. So maybe.
Just the city wasn't recognized.
Say again?
The city wasn't recognized. You have
also instead of Warsaw.
Oh. Okay.
Let's keep it in mind.
Let's do it correctly. Okay. Publish changes. All right. So, did we get an update? Maybe, maybe not. Oh, there you go. All right. So it took a while for it to be activated. But I think you get the idea. All right. You know, I spoke about the priority. So if I want to change the priority of local versus remote inference, I can do it this way. So here I specify I want to do local inference first, and then remote inference. So I can change that by just updating this JSON here. And that's also quite interesting. So for those of you who have used remote config before, you know, you might be interested to hear that we do support JSON, and because the Firebase iOS SDK supports Codable, mapping that to your Swift data structures is really straightforward. So you don't have to first spin up a JSON parser, because you can just say, read this from remote config and map it to my Swift struct. Cool. So let's go back into the presentation and see what's next. So one thing that I want to implement next for my application is to use a local orchestrator. And that local orchestrator is a locally running model which looks at the workload and it can say, oh, this looks like something that we can do locally, or this looks like something that we absolutely need to do remotely. And that can be as easy as counting the number of characters in a blog post and saying, oh, this is more than 4,096 tokens, or you could even call the model and say, here's the text, please tell me how many tokens these are. And then deciding, okay, it's too many, let's do remote inference. We are actually, as we speak, we are working on bringing hybrid AI to Firebase AI logic. So all of what I showed you today will look slightly different, because this is just like an engineering prototype. And in the SDK, we will have a feature that allows you to specify that you want to use local versus remote inference. And we're currently resolving a couple of technical hurdles because of the support for macros and stuff like that. So that's why it's taking a little bit longer than expected. But rest assured, in a couple of weeks, you'll be able to use that in the Firebase SDK. And of course, other people are working on similar stuff as well. So Matt with 3 T's has worked on something called Any Language Model. And I'm going to show you a slide how that looks like in a moment. That guy is a nice colleague of mine, and he has a video that talks about using local AI with Firebase in Chrome. So if you want to get a taste of how that will look and work like, check out that video. And here is Matt with 3 T's Any Language Model. And the cool thing about that is it is a drop-in replacement for Apple's foundation models. So at the top, you see import foundation models, and boom, we swap it out for any language model, and no need to change the code. And you can use any language model as the name implies. So you can say, I want to use Ollama, I want to use OpenAI, I want to use Gemini. All just using that. Yeah, so here are a bunch of the models that he supports. And I think in the meantime, the list probably has grown. And that's it. Thanks.
Okay, so you mentioned that it's safer than just hard coding the API key directly, like in the app binary.
Mm-hmm.
But like every app binary has some Firebase application ID, and so how is this safer when I can just take the ID and make Firebase requests programmatically?
So the API key that you mentioned is bad naming. So we should have chosen project ID rather than API key. But that's only just the first half of the answer. So the second half of the answer is you should protect your application using a feature called app check. And app check is a Firebase product that on iOS makes use of app attestation to verify that each request that arrives at the backend actually is from your legitimate application on an untempered device from an untempered application. And that is how you can make sure that any request that's coming from your device or from any devices running your application actually is a legitimate app and a legitimate request, and you can be sure that it's not anyone who's tried to hack into that. And there are ways how we can make sure that, so we've got short time use tokens in app check, for example, to ensure that even if somebody was able to eavesdrop into that communication and steal the key while it's in transport, that they wouldn't be able to use it because the time frame is just too small.
All right, do you have any other questions? Come on, one more. I'm sure you have one, at least one.
Yeah. Okay. So, do any of those models have something that allows us to return structured content?
Yes.
Any other mechanism other than just having that in a prompt?
Yeah, so in the past, you would basically have to instruct your prompt and say, please return this JSON structure. And that usually, it worked a fraction of the time. Sometimes it worked better. So Gemini is able to return structured data. And the way it works is you basically set up your, the schema that you want, and you can specify the names and the types of the attributes, and if they're optional and non-optional, and if they're nested and whatever. And then you provide this as an input when you set up the model, and then all the responses need to adhere to that schema. At the moment, it is a little bit of manual work to set this up, but we are also working on supporting macros to make that as easy as you know it from foundation models. And in foundation models, it's easy enough to set up structured data because you basically annotate your data model and you say, okay, I want this to be a generable, and then the language model knows, okay, this is the structure that I need to return. I've got a question. Do you have any Firebase stickers on you? The answer is yes. So come see me afterwards. I've got a bunch, and I'm happy to hand them out.